when we have plus or minuses, or uncertainty. The big idea here is that if the numbers you're putting into a math equation have uncertainty, then the numbers you get out of the math equation also have uncertainty. And the question is, how much? So there's several different rules we can use, and I want to start with adding and subtracting. So if we're adding two numbers, let's say we want to know the total mass when we are given mass 1 and mass 2. So for example, if mass 1 is equal to 8.56 plus or minus 0.13 kilograms, and mass 2 is equal to 5.22 plus or minus 0.08 kilograms. Let's take a look at what we would get when we add those together. Now, if we just add them together normally, ignoring the uncertainties, we get what we can consider the value of our answer. So that's just 8.56 plus 5.22. And this is going to hold true for all of our calculations. If we just want to know what the answer is, we do the math using, just ignoring the uncertainties. We do the math just using the values of the numbers that we're putting in. But we'd also like to know what the uncertainty is in our answer. So let's do it sort of without knowing what the rules are. What's the biggest the total mass could be? Well, the biggest the total mass could be is when the first mass is as big as it can possibly be, and when the second mass is as big as it can possibly be. So the biggest that the total mass could possibly be is 8.56 plus 0.13 plus 5.22 plus 0.08. So the biggest it could possibly be is 13.99 kilograms. And the smallest it can possibly be is if we subtract the uncertainty from each value. So that's 8.56 minus 0.13 plus 5.22 minus 0.08. And so we get 13.57. So that's the range of possible values. Now, and that's not subtraction like this minus that. That's like this is the smallest it could be, that's the biggest it could be. So how would we write that with uncertainty? We would say, that is 13.78 plus or minus, 13.99 minus 13.78 is plus or minus 0.21 kilograms. And I hope this makes sense, because if I do 13.78 minus 0.21, I get the smallest the answer could possibly be. And if I do 13.78 plus 0.21, I get the biggest the answer could possibly be. So the uncertainty in our answer is related to the uncertainty in the pieces we started with. The uncertainty in the answer is 0.21. Well, it's actually not a surprise that 0.21 is just equal to 0.13 plus 0.08. And this leads us to a general rule. Oh, well, let's do subtracting real quick. So if our formula was instead that the mass, we'll call this MD, the mass difference is equal to M1 minus M2, and we're going to use the same M1 and M2. So to calculate the mass difference, the difference between those two masses, we just use the regular numbers, 8.56 minus 5.22, and we get 3.34. But again, we'd like to know the plus or minus. So when we're subtracting these two numbers, the biggest answer I could get is when we add 13 to the top number and when we subtract 0.08 from the bottom number. So that's 8.56 plus 0.13 minus 5.22 minus 0.08. And that gives us 3.55 as the biggest possible value when we subtract those two numbers. And the smallest possible value is when the big number is the smallest it can be, 8.56 minus 0.13, and the smaller number is the biggest it can be, 5.22 plus 0.08. And if we subtract those two numbers, we get 3.13 as the smallest possible value of the mass difference. Okay, and again, that can be written as 3.34 plus or minus 0.21. And I hope you see that 3.34 plus 0.21 gives us 3.55, and 3.34 minus 0.21 gives us 3.13. And notice that the uncertainty was the same if we added or subtracted. In both cases, the uncertainty was 0.13 plus 0.08. All right, so this leads us to our general rule. We'll call this Rule 1. Rule 1 says, when adding or subtracting, a series of numbers, the uncertainty and the answer is the sum of the uncertainties of the individual uncertainties. So, for example, if I had an equation that said Q was equal to P plus D plus E minus F, then if I wanted to know the uncertainty in Q, it would just be the uncertainty in P plus the uncertainty in D plus the uncertainty in E plus the uncertainty in F. Now I'm writing uncertainty here as sigma. That's a Greek letter. Sigma sub Q is pronounced the uncertainty in Q. Sigma sub P is pronounced the uncertainty in P. And you get it. We just add up the uncertainties of all of the different pieces that we were adding and subtracting to get the uncertainty in the answer. That's Rule 1. Okay, so there is a corollary to Rule 1. I will call this Rule 1 star. Okay, and Rule 1 star has to do with multiplying a exact number. So let me write it this way. When we multiply a number with uncertainty by an exact number we multiply the uncertainty by the same number. And let me show you how that works. If I have 5x, or if I have g is equal to 5x, that means that g is equal to x plus x plus x plus x plus x. 1, 2, 3, 4, 5. Yeah. So the uncertainty in g is equal to the uncertainty in x plus 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 the uncertainty in x. Notice each of the things I added together, I had to add the uncertainties of all of them. So that means that the uncertainty in g is equal to 5 times the uncertainty in x. And notice, if g was equal to 5x, then the uncertainty in g was equal to 5 times the uncertainty in x. Another quick example of Rule 1 is that if the circumference of a circle is equal to 2 pi r, so 2 is an exact number, pi is an exact number, but r could have some uncertainty to it. The uncertainty in our circumference is just going to be 2 pi times the uncertainty in the radius. Because when you multiply by an exact constant, the uncertainty is also multiplied by the same exact constant. And it's really the addition rule, because 5x is just x plus x plus x plus x plus x, and I hope that makes sense. All right, let's talk about multiplication in general. So if both numbers have some uncertainty, so for example, let's say I wanted to find the area of a box, and it has a width of, call this W, and a length, no, let's do it the other way, a length and a width, and we want to find the area. We know the formula is area equals length times width. Okay, so let's give some numbers. Let's say that the length is equal to 952.5 plus or minus 0.7 meters, and the width is equal to 147.1 plus or minus 0.3 meters. And we want to calculate the area. Now again, to get the area, we just do the math as if there was no uncertainty. So the area itself, the value for our answer, is going to be 952.5 times 147.1. So the area is going to be 140,113 meters cubed. Let's see. Yeah, okay, that's my calculator rounded off. Let's not round off. 2.75 meters squared. Okay, so that is the area of our rectangle, but what's the uncertainty in that area? And here's where it gets interesting, because the length has some uncertainty. It could be a little bit shorter than what we said, 952.5, or it could be a little bit longer. And because the length has some uncertainty, that creates some uncertainty in our area. And the width also had some uncertainty. It could be a little bit shorter, or it could be a little bit longer. And that also creates some uncertainty in our area. Our area could be a little bit bigger than 140,112, or the area could be a little bit smaller than 140,112. And we want to know how much bigger or smaller could it be. And we can actually figure that out because let's look at the blue part. The blue part has an area that's equal to, if we look at this blue part here, this has a height of W and a width that's equal to the uncertainty in L, that is 0.7. And so the area of that part would be equal to W times uncertainty in L. So that would be part of the uncertainty in the area. The other part is this piece here, which has a length, L, and a height that's equal to the uncertainty in W. So if I add those two pieces together, the uncertainty in the area is equal to this piece here, which is W times the uncertainty in L, plus this part down here, which is equal to L times the uncertainty in W. Okay, so now I'm going to just rearrange some things. I'm going to divide this whole equation by A. So that means I have to divide both of these pieces by A. And on the right-hand side of the equation, I'm going to replace A with L times W. Because A is equal to L times W. And you'll see that some things cancel. Here the W's cancel, here the L's cancel, and I'm left with an equation that's maybe a little bit easy to remember. The uncertainty in the area divided by the area is equal to the uncertainty in the length divided by the length plus the uncertainty in the width divided by the width. So when we multiply two numbers, the uncertainty in the answer divided by the answer is equal to the uncertainty in the first part divided by the first part plus the uncertainty in the second part divided by the second part. So the rule number 2 says when multiplying or dividing, a series of numbers, the uncertainty in the answer, we'll call this the fractional uncertainty, in the answer is the sum of the fractional uncertainties. When I start trying to write fast, it gets really ugly. Sorry. It's the sum of the fractional uncertainties of each. How do I say it up here? Of the individual. Okay. Is the sum of the individual fractional uncertainties. All right, so there is a rule 2 star that works for powers. Because if I have, let's say I have a square, the area of the square is equal to the side times itself, so it's equal to x squared. Well, x squared is just x times x. So if I want to know the uncertainty in the area divided by the area, that's going to be the uncertainty in x over x plus the uncertainty in x over x, right? Because I've got two of them here. I need it twice in my uncertainty equation. And that could be written as just 2 times the uncertainty in x over x. So you can kind of see when there's a power here, it becomes a coefficient in front of the uncertainty in x over x. So let me do another quick example. And that says kinetic energy is equal to 1/2 mass times velocity squared. And let's say the mass is equal to 1.000 plus or minus 0.001 kilograms. And the velocity is equal to 3.00 plus or minus 0.02 meters per second. And we want to find the kinetic energy, and we also want to find the uncertainty in the kinetic energy. So to find the kinetic energy, we just use the original numbers. So 1/2 times the mass, 1.000, times the velocity squared, 3.000 squared. And we get 4.5. But now I need to know the plus or minus. So I'm going to use my rule. The uncertainty in kinetic energy divided by the kinetic energy is equal to, and now I have 3 things, well, really 4 things, that I'm multiplying together. I'm doing the velocity twice, so it counts twice. Now I'm going to work with me here for a second. One of the things we're multiplying is 1/2. So, all right, the uncertainty in 1/2 divided by 1/2 plus the uncertainty in mass divided by mass plus, now velocity is squared, so we've got 2 of them, so it's plus 2 times the uncertainty in velocity divided by velocity. Okay, let's look at the 1/2. 1/2 is an exact number, so the uncertainty in 1/2 is 0. And 0 divided by 1/2 is also 0. So I don't need that one. Because 1/2 doesn't have any uncertainty, I don't need that. So I could have just skipped that altogether and only include the parts of the equation that actually have uncertainty. Okay, so that tells me that the uncertainty in kinetic energy divided by 4.5 is equal to the uncertainty in mass, 0.001, divided by the mass, 1.000, plus 2 times the uncertainty in velocity, 0.02, divided by the velocity, 3.00. So let's go ahead and type this in. The uncertainty in kinetic energy divided by 4.5 is equal to 0.001 divided by 1 plus 2 times 0.02 divided by 3 is 0.014333. Okay? And now multiply both sides by 4.5. The uncertainty in my kinetic energy is equal to 0.0645 joules. So that is my uncertainty. Now, I want to write this correctly. So I look at my first three digits and I decide if I'm keeping one digit or two digits. And that's in the range where I'm only supposed to keep one digit. So I'm going to be saying this is 0.06 is my uncertainty. And because this has two places after the decimal, I need two places after the decimal for my 4.5. And if I go back and look at my calculator, I got exactly 4.5. But of course, it's not exact, but my next digit here is going to be a 0. Okay. So that is my final answer for the kinetic energy. It's 4.5 joules plus or minus 0.06 joules. And the reason the answer has plus or minus is because the numbers that we put into the problem also had a plus or minus. All right, so that's rule 2. And then last one I'm going to do in this video is what if we have mixed? So what if, for example, R was equal to A plus B over C? Which rule do I use? Well, this is not just addition. It's also not just subtraction or just multiplication and division. So I can't use either rule 1 or rule 2. It's mixed together. So what I'm going to have to do, because it's kind of division, right? I've got one thing divided by another thing. All right, let's give some values. Let's say that A is equal to 10 plus or minus 2. B is equal to 20 plus or minus 3. And C is equal to 30 plus or minus 1. Okay? And we're going to do A plus B over C. First thing we can do, of course, is just get the answer. A plus B is 10 plus 20, that's 30, divided by C is 30. 30 divided by 30 is 1. So my R value is just equal to 1. But what's the uncertainty in R? And it has uncertainty because each of the things we're using to calculate it also have uncertainty. Well, again, I can't use rule 1, I can't use rule 2, so I'm a little confused. Let's start by calling this X. So then R is equal to X over C. Well, now I know what to do, because the uncertainty in R over R is equal to the uncertainty in X over X plus the uncertainty in C over C. But X is equal to A plus B. So for X, I can use rule 1. And rule 1 says, let's plug in what we know. Uncertainty in R over 1, in this case, because R is equal to 1, is equal to the uncertainty in X over X. Okay, well, we know X is 30, because X is A plus B. But what's the uncertainty in X? Well, this is rule 1. So the uncertainty in X is going to be equal to the uncertainty in A plus the uncertainty in B, so that's going to be 5. Okay, plus the uncertainty in C, which is 1, divided by C, which is 30. So this is equal to, funny, they have a common denominator. It's 6 over 30, which is 1/5, which is 0.2. Okay, and now to find the uncertainty in R, we need to multiply both sides by R. which in this case is 1, but it could have been something different. So if I multiply both sides by r, I get the uncertainty in r is equal to 0.2 times 1, which is still 0.2. So the uncertainty in r is 0.2. So that means that r is equal to plus or minus 0.2. And I want to keep, since I kept the tens place in this, I want to keep the tenths place in this. So I get 1.0 plus or minus 0.2 as my value for r with its uncertainty. Okay, well, if you made it through the video, good job. And these are some examples of how we calculate uncertainty. These are the 2 rules should get us through most of our problems this year. If we need rule 3, we'll talk about it in class. And I will see you guys later.